Yeah, we're back in the zone. Falling can't ignore, it's sharking hour. Let's explore. It's not just math, it's mind in motion. Ideas flow like waves in the ocean. From numbers to science, we go deep. Dreams to chase, goals to keep. Every question's like a code to crack. Think it through, don't turn back. We don't quit, we learn with power. This is our time, sharking hour. Sharking hour, yeah, we rise and grind. Unlocking the secrets of the mind. Count, solve, feel that spark. We're shining bright, we're leaving our mark. Let's think, explore, and empower. Welcome to Sharking Hour. Ay, ay, ay. In the lab or in the class, we make ideas that last. Logic sharp and so are we. Learning strong, setting knowledge free. From algebra to chemistry flame. Every topic we play the game. Confidence grows minute by minute. Sharking hour, yeah, we're in it. No stress, just progress. We push limits, nothing less. Every challenge, every test, we rise higher than the rest. Sharking hour, now take the stage. Learning's cool, it's the new age. Solve, create, don't ever cower. Keep on shining, sharking hour. Sharking hour, yeah, we rise and grind. Unlocking the secrets of the mind. Count, solve, feel that spark. We're shining bright, we're leaving our mark. Let's think, explore, and empower. S-H-A-R-K, yeah. Yeah, we're back in the zone. Grab your pen, switch your phone. Knowledge calling, can't ignore. It's sharking hour, let's explore. It's not just math, it's mind in motion. Ideas flow like waves in the ocean. From numbers to science, we go deep. Dreams to chase.
All right. Good evening, everyone. Greetings to you wherever you are watching us from. I'm glad you decided to join today's live stream. All right. So if you're watching and you're from any other country aside from Ghana, please let me know in the live chat where you are joining from so that I can appreciate you. All right. So today's live stream is going to be on physics. So we'll be looking at physics. Specifically, we'll be looking at the topic that we call dimensional equations in physics. Now, if this is something that you are really interested in, please stick around with me. And if it's not, and it's something that is new to you, also stick around and learn with us. Now, unlike the conventional way we've been going, where we solve a lot of past questions, I write the multiple choice questions, you guys give me the answers, and we go back and forth. Today, we want to look at some lectures, right? We want to have some lectures in or on physics, right? So with time, we'll be moving from physics to mathematics to chemistry and to other subjects as well. But we will be taking a particular subject, then I teach it. We look at examples before we go onto the past questions. All right, so today, like I said, we are going to be doing physics live stream, and then the topic we'll be looking at is what we call dimensional equations. All right, so let's begin by actually having a look at what dimensional equations are all about. Okay, So let's begin. Okay. All right. So like I said, today we'll be looking at what we call dimensional equations. Dimensional equations. This is the topic that we'll be looking at. Okay. And under dimensional equations, we'll be looking at how to find the dimension of certain quantities, and then also how to check the validity of an equation, how to prove that a particular equation is valid, and many others. All right, so basically when we are talking about dimensional equations, this all comes down to what we call base and derived units. So most of our concept is going to be derived from the base and derived unit kind of concept. Are we okay? So for instance, we have what we call our base unit. Then we also have what we call our derived unit. Just a moment. Okay, so my pen is working well now. Okay, so we have what we call the base unit and the derived unit. So basically what we mean by base and derived unit is that for base units, these are units that are fundamental, right? They don't come from the combination of any two or more units. So that is what we call base units. Now, when we talk about derived units, we are talking about units or units of measurement that are obtained by either addition, subtraction, multiplication, or division, or we are adding two or more base units, right? So for a fundamental or base unit, we call them base or fundamental units. Base or fundamental units, we are saying these are units of measurement which are fundamental. They are not obtained by combining two or more different units. But when it comes to derived units are obtained from two or more units. Are we okay? So those are that of base unit and derived unit. Now when it comes to dimensional equations, okay, you guys can see now, very good. Now, when it comes to dimensional equations, our focus here is on the base unit. Are you okay? Specifically, the three fundamental base units that we have. So, ideally, we have 7 base units. Okay, we have 7 base units. We have the length. So, let me quickly draw that table for us. So, we have 7 base units. We have the quantity, and then the unit, and then the symbol. So let's look at the quantity, the symbol, and the unit. Okay, so we have length as one of our quantities. We have mass, we have time, we have electric current. Okay, so this is 1, this is 2, this is 3, this is 4. Then we have 5. We have a thermodynamic temperature. So thermodynamic temperature, I'll make this like this. Then we have luminous intensity. And then the last one we have is amount of substance, or mole. Amount of substance. Are you okay? So these are the 7 units that we have, and from this unit we have the symbol for length. It is measured in meters. So the symbol here is m. The unit of measurement is in meters. Are we okay? For mass, it is in kilogram. So we have here kilogram. For time here, it is in seconds. So we have here, we have here s rather, and seconds in the next one. So we have here s. For electric current, it is in amperes. For thermodynamic temperature, it is in Kelvin. luminous intensity, it is in candela, so we have CD. The amount of substance is in mole. Are we okay? So here, this is in seconds for time. Electric current is in amperes. Thermodynamic temperature is measured in Kelvin, that's the unit. Luminous intensity is measured in candela. Then the amount of substance is measured in moles. Are we okay? So these are the base units that we do have. Okay, but the fundamental base unit are the first three that we have over here. So the fundamental ones are our length, which is measured in meters. Okay, then we have our mass, which is measured in kilogram. And then we have our time, which is measured in seconds. Okay, so these are the three parameters that we will be using in our dimensional equations. Are we okay? Now, for dimensional equations, the definition of dimensional equations are these are equations which express a physical quantity in terms of their dimension. So what we basically mean is that, for instance, if I take the three units of measurement, the basic one that we have, so we have here length, then we have here mass, then we have here time. Are we okay? So these are the units. Okay, but if I apply dimension to it, or I want to find their dimensional analysis, I put them into this solid bracket. So this means the dimension of length. Are we okay? And then for that of mass, we have this dimension of mass, and for time, we have the dimension of time to be this. Are we okay? Now, to express these guys in their respective dimensions, we use the first alphabet that starts the name of the quantity. So in length, it is L, so we use capital L. For mass, it is M, so we use capital M. For time, it is T, so we use capital T. So these three now becomes the dimension of length, mass, and time. Are we okay? So now that we have these three basic or these three fundamental units and their dimensions, we can use that to find the dimensions of any other physical quantity that we get. For instance, let's look at speed. Okay, speed. Now, speed is defined as the distance traveled over the time taken. Okay, that is the definition of speed. Now, if you want to find the dimension of speed, it means that we'll put speed into this bracket. So we have the dimension of speed that will be equal to the dimension of distance. Are we okay? Over the dimension of time taken. Now, if this is the case, then the dimension of distance is a form of length. Are we okay? Distance is a form of length. So in place of distance over here, we have L. Then over here, the time is still obviously time. So we have T over here. So we can rewrite the dimension of speed to be LT raised to the power -1. So this becomes the dimension of speed. Are we okay? All right. So now that we know this is the dimension of speed, let's proceed to look at the dimension of other physical quantities. All right. So let's look at area. Let's look at area, the dimension of area. Okay. Now for area, we know area is length multiplied by breadth. Okay, or width, depending on what you are looking at. For instance, if I have these two dimensional shape, okay, I have my length, my breadth all here, or someone can say my width. It depends on how you are looking at it. But the area over here, so the dimension of area will be equal to the dimension of length multiplied by the dimension of the width or the breadth. So let me still use the breadth over here. Are we okay? Now from here, we know that breadth and length, they are all type of length. Are we okay? They are all length. So the dimension of length over here is L, multiplied by the dimension of breadth over here is also L. So over here, our dimension for area will be L squared. So this is the dimension of area. All right, so let's proceed to look at the dimension of a volume. Okay, when we talk about the physical quantity or the quantity volume, let's look at the dimension of a volume. Say we have this three-sided box over here. Okay, so this is the box that we have over here. So we have the length here, we have the width here. So the length, the width, then so no, this is rather the length, this is the width, and this is the height. Are we okay? So we have this. Now, if we were asked to find the volume of this particular object, our volume will be equal to the length multiplied by the width multiplied by the height. Are we okay? So from here, if we are finding the dimension of volume, it means that the dimension of volume will be the dimension of length multiplied by the dimension of width multiplied by the dimension of height. Are you okay? Now, if we look through all of this, the length, the width, and then the height, they are all types of distance. Are we okay? They are all types of distance or length. Are we okay? So basically, all this is just length multiplied by length multiplied by length. Are we okay? So here it is just L multiplied by the width. The dimension of the width will also be L. The dimension of the height will also be L. So over here, we'll have L cubed as our answer for this particular question. So now that we've looked at speed, we've looked at area, we've looked at volume, let's look at other complicated quantities. For instance, let's have a look at density. Okay, let's have a look at density. So now in dimensional analysis, the most important part of dimensional analysis is you knowing the formula for the quantity that you are given. Are we okay? So over here, the density of an object or a shape or something is the density is the mass over the volume. Okay, this is the formula for calculating the density of any particular shape, figure, or something. Now, this is the general formula. So when you want to find the dimension for density, so the dimension of density becomes the dimension of mass, okay, over the dimension of volume. Okay, now like I said, volume, for instance, we can still break this down as mass over volume. We know volume is length, okay, times breadth times height. Are we okay? So when we apply, we know all these are in dimensional analysis, they are all lengths. So we can assume this is L multiplied by L multiplied by L, which will be L cubed. So from here, our dimension for density will be equal to mass, which is the dimension of mass is M, over the dimension of volume. Okay, from here, what we can see over here at the bottom is L multiplied by L multiplied by L, so it will be L cubed. Are we okay? So from here, our dimension for density will be equal to ml raised to the power -3. Are we okay? That is if we are writing it in a linear way. So this becomes the dimension of this parameter that we are calling density. All right, now let's look at acceleration. Let's look at acceleration and look at the dimension for acceleration. So when we talk about acceleration, okay, acceleration in this case is equal to the velocity over the time taken. Are we okay? And in this case, if we are applying dimension to them, so we have the dimension of acceleration will be equal to the dimension of velocity over the dimension of time taken. Now, one thing we need to note is that before we even go in there, velocity equals distance over time. Distance over time. Okay, so if we find the dimension for velocity, what we will get is velocity is distance. Distance is a type of length, so it will be L over time is T. So velocity itself has a dimension LT raised to the power negative 1. So now that we have this, it means that the dimension of acceleration, let me use A, will be equal to velocity, which is LT minus 1, divided by the dimension of time, which is T over here. So this becomes LT minus 1, then T minus 1. So we have 2T raised to the power minus 1, so we add the two of them. So this becomes LT minus 1 plus minus 1, and that will obviously give us LT minus 2. So this becomes the dimension for acceleration. Are we okay? All right. So let's look at other parameters. So let's look at force and let's look at pressure. So for force, okay, we have here force is equal to mass times acceleration. Force is equal to mass times acceleration. Then if we look at it, the dimension of force will be equal to the dimension of mass multiplied by that of acceleration. Okay, now we can further break this down to be the dimension of force will be equal to that of mass multiplied by acceleration. Acceleration, we know acceleration is velocity over time. Are we okay? So we can break this down like this. And we know velocity is also distance over time, but we will not break that further down. So from here, we know force is equal to the dimension of mass is m. So here multiplied by, for velocity, we already looked at that is LT minus 1 over time here, which is LT. So here we have m. This side becomes LT minus 2. We already looked at the dimension of acceleration. So over here, our final dimension for force is MLT minus 2. Are we okay? So yes, this becomes the dimension of acceleration. And if we look at that of pressure, okay, so pressure, mathematically, when we want to define pressure, we are saying pressure equals force over area. Pressure is force over area. Are we okay? So now that we know pressure is force over area, our dimension of pressure will be equal to the dimension of force on the dimension of area. Are we okay? And so from here, we have the dimension of force. We've already found it. That is MLT minus 2 over that of area. We know area is length times breadth. So those both are length. So we have L squared at the bottom. So here we'll have MLT minus 2. Then we set the L square upside down to become L minus 2. So we have 2L over here. So we'll add their powers. Here is 1, here is negative 2. So here we'll have ML minus 1, T minus 2. And that becomes the dimension of our pressure in this particular instance. All right, so let's proceed to look at, now we've looked at dimension. What are some of the uses? Why are we learning this? What are the uses of the dimensions? So uses of dimensions. So one of the uses of dimension is that we use it to find the units of measurement, right? So we use it to find the units of measurement. Okay, so that is one of the uses of dimensional analysis. We also use it to derive equations between quantities. Okay, as in what is the relationship between area and pressure and all those things. We also use dimensional analysis to do that. Lastly, we also use that dimensional analysis to check the validity of an equation. Validity of an equation. Okay, now these are all things that we can do. For instance, we know that from our lessons, we know that the dimension of velocity, are you okay? We said that is LT minus 1. Are you okay? So how do we find the unit of measurement from this particular dimension? Now, this is telling me this is length multiplied by time raised to the power negative 1. So I know that my length is measured in meters. I know that my time is measured in seconds. So I put the negative 1 over here. So this is the unit for velocity. Are you okay? Do we see how easy it is to just derive the unit of measurement from the dimension? Are you okay? Now, if we go back, let's look at what we had for force. Form is MLT minus 2. So for force, what we got was MLT minus 2. So it means that in case I ever forget that force is measured in newtons, if I remember the dimension, all I need to do is that my mass is measured in here. This is MLT. So the M over here, the capital M over here is for mass. Okay, so mass we know is measured in kilogram. Then the length we know is measured in meters. And then the time we know is measured in seconds. So this we just put the minus 2 over here. And this becomes the unit of measurement for force. Are we okay? The same way, if we look at pressure, we had ML minus 1, T minus 2. So for pressure, let me do that here. For pressure, it was ML minus 1, T minus 2. So from here, like I said, the M is the mass, and that is in kilogram. The L is the length, and that is in meters. So meters per meters. And then the time is in seconds. So S minus 2. Okay, so this becomes the unit for measurement for pressure. So this is how easy it is to find a unit of measurement from pressure. Are we okay? Now, to check the validity of an equation, there's a way we also do that. Are we okay? So basically, when you are given two equations and they involve two quantities, we try to express the dimension of both quantities on the left hand side and then the right hand side, and then we compare. We ignore the coefficients. For instance, if I have an equation and then the dimension is, let's say, 2LT minus 1 is equal to 15LT minus 1. Are we okay? Now, my focus over here will just be on the LT minus 1, LT minus 1, and not the coefficients. Are we okay? So if the dimensions are the same, we are saying that the equations are valid. Are we okay? And then this also tells us the relationship between quantities. Are we okay? For instance, there are questions that you'll be given, and when you solve, you realize that, let's say, force. No, let me use pressure in this case. Pressure, we are saying is force, okay, over area. Okay, but then we can use dimensional analysis to show how pressure is related to a force which is directly proportional, and how it is related to area which is inversely proportional. So we can also use dimensional equations to find that as well. So yes, this is the concept of dimensional analysis. This is what dimensional analysis is all about. It's all about just expressing physical quantities in terms of their dimensions. And like I said, we basically use three things: the mass, the length, and the time. Those are the things we use. And then when it is mass, we use the capital M that starts the mass. When it is length, we use the L that starts it. Then when it is time, we use T that starts it. Are we okay? All right. So now that we are done with dimensional equations, let's quickly solve some objective questions in physics before we go. So let's solve some basic physics questions, objective questions, and then we go. Okay, so there are some dimensional equations questions here, but we are going to jump that for the time being. Okay, so let me get a question on dimensional analysis. Since we are doing that, let's just look at some questions on dimensional analysis, and then we solve them. All right. So over here, the question is saying, write down the dimensions of the following quantities. Okay, so this is a past question. So we have to write down so here we have to write down the dimensions. We have to write down the dimensions of the following physical quantities. So we have here alpha, we have acceleration, beta, we have pressure, and then gamma, we have density. Okay, so this is the question. Let's go ahead and look at the solution to this problem. This we've already solved. We said that for acceleration, so here's our solution. We said that for acceleration, this is equal to velocity over time. And then if we apply the dimension to them, we have velocity, the dimension of velocity to the dimension of the time taken. And that will be equal to velocity we know is LT minus 1. So this will be divided by T. And then this becomes LT minus 2. Are we okay? For pressure, we know pressure is force over area. And so from here, our force, okay, force we know is mass times acceleration. So let's just split that. And then all over area. So we can apply the dimension to all of them. We know mass is capital M. Acceleration, we just found it over here. So it's LT minus 2. And then the area is length times length. So we have here L squared. Okay, so finally, if we send the L to the top or the L here, cancel one of the L here, we'll get one at the bottom. So our final answer here will be ML minus 1 T minus 2. This becomes our answer for this particular one. And then when we look at the last one, which is density in this case, okay, we know density is mass over volume. And so from here we have mass, the dimension of mass over the dimension of volume. And then mass is M, volume is L cube. Okay, that is length times length times length. So we have ML minus cube over here as the dimension for this particular problem. Okay, so yes guys, these are some basic concept on dimension. Now with time we'll be looking at tougher versus questions, but today I just felt like let's do this quickly, something to wrap up, and then we can call it a day. So thank you so much for watching. From here exactly at 7:50 we will be looking at IQ test questions. So I will see you in that particular live stream. Thank you so much, and bye bye.